So I'm Marc Cohn, and today I'm representing the ONF, and what I want to talk about is the intersection between SDN and NFV, and also talk about the role of OpenDaylight in that overall discussion. For those of you who don't know, I actually lead the market area for the Open Networking Foundation, and in addition, I serve as on the board of directors of OpenDaylight. I represent the silver level membership, which is, I think, around 35 members now. It's changing daily. And have been involved in SDN for quite a long time. So where I want to start is just to look at what's really happening with regard to deployment of SDN. And I just want to cite some market research. And I ran across this data point from light reading. It said that it was the slow shift to SDN. But when I looked at the numbers, it was around 2/3 of the respondents surveyed intend to deploy by next year. I'm not so sure how much faster we can go in the carrier segment of the industry. I mean, it seems like that. If this is the case, I think that's very encouraging. And our good friend Michael Howard, who's been running around this event, and I think many of you are familiar with Infinetics, his prediction is that there's going to be a huge market for SDN and NFV hardware that is likely to incorporate software. I think it's going to be difficult to separate it out by 2018. Or in other words, even though the market research process has some uncertainties, the perception right now is that NFV and SDN is not just something interesting, it's going to be deployed in a very big way. And it's going to happen in the next couple of years. And we've seen nothing but that, nothing to refute that during this event. So first thing I want to do is contrast SDN and NFV. Because again, and you might be wondering why I'm putting this slide up. But if you look at it, this slide indicates why SDN and NFV, at least in I would argue that SDN and NFV have a lot of similarities, and that's why there's such a close and tight interaction between the two initiatives. Now, if we look at what are we attempting to do? We're attempting to virtualize networks with SDN, whereas we're trying to virtualize network software with NFV. And I say network software because I think NFV, from an architecture perspective, is not just about virtualized appliances. I mean, that's part of it. But I think that we're also going to see everything virtualized based on this architecture. And if we look at some examples, one of them is going to be an SDN controller. So I think that there's going to be a direct relationship between SDN and NFV when we look at the actual implementation. The value proposition is pretty close. It's not identical. I mean, it's in a word, agility, and it means speeding up everything. Speeding up network changes, speeding up deployment, speeding up new service creation, speeding up, scale down. Really everything it needs to be accelerated, or actually will be accelerated by deployment of SDN and NFV. It's also about cost reduction. I mean, there's the triple play value proposition here. It's about enabling new revenues by speeding up everything, time to marketing improvements, new services, and at the same time being able to streamline operations, which is where the majority of the expenditures are, as we've heard actually throughout the first couple of days of this event. And then at the same time, being able to optimize resource utilization to drive down CapEx costs as well. You know, in other words, the CapEx play is not so much about commoditization, even though there's a lot of discussion about that in the data center segment. It's really about optimizing resources that are already there. Or in other words, think about it in terms of improving the service density per cubic meter or by watt. You know, the cloud-like metrics, not just the traditional telecommunications metrics. And then, is there a dependency? Of course there's a dependency, and I'll get into why I believe that's the case in just a minute. So, this is a chart that classifies the 10 use cases that constitute network functions virtualization, again, based on the ETSI NFV, Industry Specification Group, which is the organization that actually created the NFV requirements baseline, and is now just recently, as of the last meeting in February, moving into the implementation phase. And if we look at this, it's actually pretty interesting for a couple of reasons. First of all, it spans a whole range of different applications. Everything from the mobile network, which we're seeing in this event, quite a bit of attention given to virtualized DPC and virtualized IMS and a whole range of virtualized applications, to CDNs, and even down to residential, where we've seen a lot of attention given to virtualized CPE. And virtualized CPE was one of the highlights, I think, yesterday for those of you who were fortunate enough to attend the keynotes, to get a sense of what that value proposition really is. And it goes back to my previous slide, which is faster everything. And it's the use cases on the left, though, that I think are some of the most interesting ones, which the group refers to as framework or infrastructure use cases. You know, VNF as a service, NFVI as a service, you know, for the and service chaining. All of these have their roots in the cloud, and as a result, there is certain network requirements that are applied when we talk about deploying anything in the cloud, which is why we're going to need a dynamic network architecture like SDN to enable dynamic services that are going to be delivered in NFV, or at least enabled in NFV. So if we look at some of those requirements, what's the first one? Well, clearly we need to be able to automate. So rapid configuration, rapid provisioning, rapid change. That's one of the first requirements that's implied by enabling the cloud, not only the cloud use cases, but all the use cases. If we're deploying virtualized CPE, we certainly are going to need automation to be able to allow for the kind of on-demand deployment that major operators are looking for. And then to be able to take advantage of the dynamic nature to scale up and down, that's certainly another aspect. Performance on demand, another key requirement. You know, if we're going to be moving we're going to be doing things like moving VMs or making broad changes. The idea is to just request resources on demand, and then being able to move these resources around the network in an orderly fashion, again, a la the cloud. We need to dramatically reduce the cost per gigabit. And that's not a typo, it's gigabit, because I'm thinking closer and closer to the core of the network. And the real challenge is, and you've seen this from and heard this from a number of operators, which is the revenue that they're able to generate per user at least is relatively flat, but the demands on the network continue to grow pretty dramatically. I mean, some of the data points that we've been able to gather, things like, you know, multi-100% growth over 4 or 5 years of traffic. Those are things that you cannot possibly address without some disruptive change to the architecture. And that disruptive change is going to be SDN. I mean, one of the data points, AT&T at an event, it's about a year old or so, mentioned that I think that in 4 years their traffic grew by 3,500%. And if that's really the case, how are you going to be able to address that, given that YouTube became the second largest search engine, meaning video is just taking over everything. Everybody wants to an iPhone 6 so that we can watch things in HD, and guess what's on the horizon in the mobile world? We're going to see Ultra HD or some attempt to create a higher resolution service to differentiate. All of these things are going to continue to result in exponential traffic growth. Next is elasticity, and again, you can't have a dynamic capability if you can't scale down as well. It's not just about scaling up. And elasticity allows us to take advantage and exploit the pooling of resources in the network. And I don't think that there's anything here that's really that dramatic. The point of this is that if you really take a step back and look at what NFV represents, it represents a dynamic capability that has to have some underlying dynamic network services enabled to support it. Resiliency, and that is changing as we'll see in a minute. And then of course openness, which is one of the key differences when we talk about SDN and NFV relative to similar things that we've been doing in the industry, probably going back 10 or 20 years, if you really look at it, but almost only in a proprietary architecture. And those networking requirements are going to be addressed by the SDN architecture. This is just the familiar ONF three-layer architecture that I think many of you have seen various different versions of over the last couple of years. We forged this around 2012, so it's been out and it hasn't really appreciably changed much. But the idea is to be able to provide a network that has programmability, which is one of the key aspects and the key departures from today's networking architectures. Programmability in the sense of allowing network software to actually change the forwarding behavior of the network. And then in addition, programmability enables the automation that we need to be able to achieve the agility that operators are looking for, and the cost savings by streamlining operations, and again, by automating primarily. So one aspect is programmability. The second one, of course, is the logically centralized control. And this is different than, I'm going to split the control plane and data plane, which is sort of the classic, simplistic definition of software-defined networking. And for those of you who joined us yesterday at our lunchtime debating table where we had this topic, I see at least a few of you, please bear with me because we talked about some of these things yesterday. But logically centralized control means that we want to be able to exploit a domain view and implement functions that can take advantage of having a domain visibility and centralize those functions. And then other functions are going to be embedded into the hardware, and we're going to actually implement a blended model. So logically centralized control really implies more of a hybrid approach to the control plane. And then finally, the third key attribute that's going to address NFV networking requirements is abstraction. And abstraction allows for network applications, or actually SDN applications, the highest level applications, to be able to leverage, very diverse applications to be leveraging a common control layer. And then at the same time, providing a similar level of abstraction to enable multiple different networking devices to be able to be integrated and controlled by a common control layer. And those multiple different types of networking devices, you might think of those as there's different ways of looking at it. Some are by layer. Certainly we could have optical devices, we could have routers, and everything in between. Another way to look at it is multi-vendor, meaning even if we had network switches, they're in layer 2, but depending on vendor A, B, or C, how they implement them, they could be very different. And then the third way to look at it, which is maybe the first way of looking at it, if you think about, and for those of you who are operators and are deploying large-scale network deployments, what we're seeing is that even for a particular vendor, do we have one management system that can manage all that equipment? It's very difficult to do. I represent an OEM, and we've struggled with it, and everybody has struggled with it. So the first order of business with SDN and to enable a dynamic NFV network infrastructure is to be able to provide this multi-vendor interoperability for a single vendor who has very disparate product lines and can be wrapped up into a common architecture. Another key component of the network that's necessary for NFV is the common and open controller framework. And I'm using that term very precisely. Controller framework. OpenDaylight is a controller framework. ONOS, REU. These are not controllers. A controller adopts an open controller framework and then provides all of the other hooks that are necessary to deliver a product to an end user. The open source community, and if you look at Phil's chart, let's look at the membership of OpenDaylight. It's OEMs. It's not a number of operators. There are operators who are interested, but the key contributors are OEMs. OEMs, and it's not surprising because the OEMs are going to adopt the open source, and one of the models that Phil had in his slide was adopting open source into proprietary products. That will be the model. However, by actually adopting that open controller framework, we're going to be able to take advantage of some of the benefits on the right-hand side, including providing a platform that's extensible enough to plug in different functionality, to be able to extend and change and innovate over time. We want to leverage open source. Phil had we've talked a lot about open source in this event. I don't need to go over all the benefits once again, but there are many. And we want to be able to take advantage of open source where it makes sense. And where it makes sense from an OEM's perspective is where we cannot differentiate. And it's also in the interest of the end user to be able to adopt that capability. Like, we'd like to have common northbound API framework, as we discussed in our talk yesterday, that will allow for applications, no matter what the different characteristics of those applications, to be able to integrate and even be able to move from controller to controller that adopts that common API framework. That's clearly in the interest of the operator. And we want to be able to also provide migration. And this is something that OpenDaylight has actually implemented from the beginning. It's a service abstraction layer, for those of you who are familiar with the architecture, that's shown on the left-hand side, that allows for different types of devices who don't necessarily implement network standards like netconf and ultimately OpenFlow, the open programmable interface, to provide the completely programmable open network. There will be many steps along the way. Different operators are on different investment cycles, they're on different trajectories, they have different priorities in terms of how they intend to migrate and realize the vision of SDN. Another key benefit of the open controller framework is to capitalize on the community. And when Phil was talking about what's the difference, what makes an open source project successful, this is what makes it successful. And if we look at what, there's millions of open source projects, how many are really successful? Not many. And that's because it's very difficult, expensive, time-consuming, and politically challenging to create a successful community. To be able to bring together organizations that traditionally compete, that sit at different levels in the overall industry, and then be able to sort of point them in generally the positive direction. And then to be able to incentivize individual contributors and corporations that are primarily supporting the developers who are contributing to some of these major open source projects, to guide them to make sure that they are not only contributing code, but they're contributing code that is of use to the end users and operators who are actually planning to deploy the products that adopt that open source. So the community is the really key. And if you look at OpenDaylight, there's over 300 contributors right now. There's probably 1,000 or 1,500 developers that are working on OpenDaylight-based products. And that's a broad community. OpenStack's a broad community. So there's others as well. It's not just that there's actually, Linux is the ultimate community. When you look at the scope of Linux and how it's ended up in every computer, or many computers. And then finally, we want to incentivize multi-vendor participation. It's not just about multiple vendors are sitting in one roof. That's a little easier. One vendor can actually try to get all those vendors together with various different means. But the real question is, how do you create a process that allows us to incentivize everybody who wants to participate? And the key here is being able to create an open framework that is not controlled by a single organization. That's the definition of openness that the Open Networking Foundation has subscribed to. So when you're evaluating open source projects, and you're looking at community, and you're looking at the implications from openness, an open ecosystem, is there one vendor driving the whole thing? Then it's not open by the Open Networking Foundation's definition. So let's take a look at some of the adoption considerations as well. I mean, first, let's look at the vision. And if we go back to a couple of years, the vision before NFV even existed was SDN. If you think about 2011, 2012, 2013, and my timeline doesn't go far enough back, but it really was about SDN. And then all of a sudden, around 2013-14 timeframe, it was NFV. SDN was something, it could be 10 years in the future, it could be forever, who knows. And then now, what happened? Look at the event. Look at this event, from the keynotes to the workshop that we had on OPNFV on Monday. I mean, clearly, it's about NFV and SDN working together. The target was originally moved from the physical to the virtual world. I think everybody can appreciate that. But it's really more about services. And that's where we're starting to evolve now, with service chaining, with a lot of the activities that are underway to actually transform a series of virtualized or VMs or even containers or virtualized entities and creating services wrapped around those. Robustness, the model is changed by the cloud. And we're going from, even in telecommunications, we're going from a reliability-driven model to an availability-driven model. And anyone who's seen the hyperscale operator story, Google, Facebook, and so forth, you get a sense of really what they're thinking about in terms of trying to implement horizontal scalability, where adding hardware to the network is not about adding redundancy, it's about adding capacity. And telecommunications is going to subscribe to that as well. And then finally, how do we validate what we're doing? This is really key. It's not enough to have an open source community where anybody can contribute anything. That's nice. That makes developers feel good, but from an end user perspective, we have to have some way of validating that the deliverables are going to address the needs of the end user constituents who are going to actually purchase the products that adopt the open source. So we started with a model of standards, open standards, and we moved from the closed standard model, which is a handful of individuals who used to meet as a profession all around the world, spending years of time to be able to create a technology capability that took many, many years to actually realize. Then we started to embrace open source. And there's no question open source has a key role in validating not only that there is a need, but the requirements themselves. If we can't implement something, how could we create the NFV architectural framework without some level of implementation? And of course, that was where OPNFV came from. And now we're at the point where we're going to be embracing open reference platforms as that means of being able to not only look at an individual component like the open controller framework, but to be able to integrate the whole piece, the whole architecture around a number of open source components that have prescribed interfaces and be able to validate that they actually address the overall capability of delivering services to end users. So finally, you might wonder, think about the theme of this presentation was how SDN enables NFV. And again, the industry has progressed dramatically in just the last year and a half, where we were still having to debate whether it's SDN or NFV or which is first. Well, now I think clearly anyone who has looked into this and looked at what AT&T is doing, they were leading the charge way back in 2013 and even before that with the introduction of Domain 2.0, which is their SDN and NFV strategy. Margaret gave a presentation and insights into what AT&T is doing today, and clearly the two are very closely integrated together. NTT is another who's embraced this. This is a news item from last year about the NTT global cloud services that leverage SDN and NFV. If we keep thinking more closer to home, Verizon just announced the vendors that they want to work with for their carrier SDN architecture that's going to enable their service delivery based on NFV. A couple days ago at one of the keynotes, Deutsche Telekom announced the delivery of their cloud VPN service based on SDN and NFV. This is just, I think the press release was March 3rd, Mobile World Congress. So for those of you who are in Barcelona in March, you remember this. But I think Ray LeMaitre from Light Reading, I think he coined it the best about the relationship of SDN and NFV, which is there really is no going back. And I think we're going to see this moving forward, especially as things unfold over the next year. So I don't know if we have time for a question or so. I think we're running out. Or
Take one.
Do we have a question?